Hello, my name is Clint Savage. I'm a senior software engineer here at Red Hat, and I work on a project called LinchPin, which I'd like to show you today. We're going to talk a little bit about how LinchPin works. We're going to talk about pin files and topologies and layouts and how they all work together inside of a workspace, along with our credentials and for hooks with a particular openstack instance. And we're going to provision one node, and we're going to show you how to set up a hook that can be provisioned after, or can be used after the provisioning to make this work for you. So let me show you a little bit about LinchPin, and then we'll move right into that process. First off, I'm using LinchPin version 1.0.3. And if you run LinchPin help, you can see all the command options that are available to you. You can do a configuration, specify your own pin file, and you can work in a workspace, which we're going to show you in just a moment here. You can also do an initialization. You can set up provisioning so it'll bring it up, or destroy where it tears it down. And we also have a function for fetching workspaces as well. So what I'm going to do right now is I'm going to create a workspace because I don't actually have one, and I'm going to call it example WS here. And then I'm going to change into that directory. And I'm going to first create a pin file. The pin file is kind of the component that stores everything for us in one place so that we can actually use it. It has a single target, or multiple targets if you wish. And then those targets are associated with a topology, a layout, which makes Ansible inventories. And then we can actually also have hooks as well. And we'll see how that lays out here in a moment. So let's go ahead and create the pin file, which is a YAML file at the moment, and I'm going to give it a target, which I'm going to call OS single test. From that, I'm going to create a topology. I haven't created the topology yet, but I'm going to tell it, hey, this is where it's at. It's called openstack single.yaml, and a layout, also called openstack single.yaml. These live in different directories, so they won't collide. And I'm going to save that file. You can see it here. Next, I'm going to create a directory called topologies and a directory called layouts so that they can put those two files in there. Now I'm going to go ahead and create the openstack single.yaml inside the topologies directory. So let's go through that. First, I'm going to create a topology name, OS single. Give it a resource group setup. You can have multiple resource groups. You could have an OpenStack one, an AWS one, libvirt, whatever you'd like. You can combine them in any way you like. And then I'm going to go ahead and give it a resource group type as well as a name. In this case, the type is called OpenStack directly because we're going to be using OpenStack type nodes. And so we'll be using that. And then we have a group of definitions that go with that OpenStack group. And that first one will be a named example, and then it will be of type OS server. This corresponds to the Ansible module OS server as well. So if you look at the Ansible module, this will be what we give arguments to, and we pass them along for you. The flavor is M1 small, and the image, this long image, rel72 server released. These pieces of information will be passed to that module, as I mentioned. We'll also be able to provide a count. You can do there's no argument required here for this one. It's optional, but it defaults to 1. If you want to specify more, you can provide that there. Additionally, you can get a key pair. The key pair is the public key that you've put on the OpenStack server. You name it and call it in this case CI factory. And I'm going to have a private key, which I'll show you in a moment when we do a little bit more work that associates that. That's useful for when we want to connect to it after the fact. Then I'm going to create a network. This is a private network. I'm associating with the Atomic E2E Jenkins test network. And finally, I'm going to add an IP address from the floating IP pool as well, if you have that feature available. If not, it's an optional argument. Lastly, we're going to do some credentials. And I mentioned this earlier, but I'm going to give it a file name called clouds.yaml. If you want to use the environment variables from OpenStack, you totally can. Clouds.yaml is just another way of giving authentication mechanisms so you don't have to provide it directly to someone and you can just log in automatically like you normally would. And then I'm going to give it a profile. The profile in this case is called CIOSP, and we'll get to see how that looks in just a moment. So let's create the layout file now. The layout file lets us create an Ansible inventory. It again is YAML. And so we'll go ahead and create an inventory layout header. We'll give it a set of global variables. In this case, I want one called hostname, and it will give it the IP address associated with that particular node, and that's interpolated automatically by when we return the data from OpenStack or from any of the providers. And then I'm going to create a list of hosts that I want to group together. So we only have one in this case, but if we had multiple, we could actually create different groups that they're associated with. In this case, it's only associated with the example group, but you could create it to work with like the web servers group or the databases group or whatever you like. And then you can target those in your hooks. So let's show you what the credentials looks like now. We're going to show you clouds.yaml. This is a sample. The one I'm going to use is actually in the openstack directory, not the LinchPin directory, but this is a dummy one that looks pretty close to what you'll see. What you'll notice is I have one called CIOSP right here, and it has an auth URL, a project, a username, and a password. Then I'm going to go ahead and modify the pin file. And I'm going to add a hook now. This hook is going to give us the functionality, as I mentioned earlier, to do something after, in this case, which we call a post-up hook. We do have a pre-up hook, a post-destroy hook, and a pre-destroy hook if you ever want to use them. This is probably going to be the most common one, though, where we're going to do something after the systems are provisioned. In this case, it's a type Ansible, and it's named ping, because we're just doing a simple ping. Then we're going to give it a context. Well, this is giving us the ability to access the environment variables around that Ansible inventory that I mentioned. We generate that Ansible inventory automatically with the layout above. I can then specify some actions. In this case, a playbook called osping.yaml. I could have did it YML. I don't know why I chose AML. And then I'm going to give it some extra vars. Now, I mentioned earlier that CI factory key. This is the private key that's associated with it. It's just a big long path, and that's the environment variable that Ansible takes to accept it so that we can map this out. So that's pretty much straightforward. Should be pretty much all you need. And then from here, I'm going to cat that pin file just so you guys can see what it looks like. All right, now, because I'm going to make those hooks, you can kind of see the layout here. What we're going to do is we're going to create a hooks directory. And then we're going to create an Ansible directory, and then we're going to create a ping directory. And you kind of see that laid out here in this line. So let me go ahead and hit enter here, and that makes the directory. And then I'm going to make a file called osping.yaml. In that file, it's pretty straightforward. Ansible likes YAML too. We're going to specify that example group I mentioned before, and we're going to assign some tasks to it. In this case, just one, the ping task. And that is it, literally all there is to it. To making a ping one. We could make another playbook or could do a whole bunch of other things. You can add all sorts of environmental variables and tinker with it however you wish. So let's look at that and just kind of see the structure just so we kind of get a hang of it. The last thing that we might want to do is, because we're creating a brand new system, the SSH nodes, when they come up, they'll actually generate SSH keys for the host. Those keys are going to probably fail unless you ignore them. So this is what I'm doing here. But this is mostly for testing. I wouldn't do this in a production environment. So if you're interested in learning how to do it a different way, there are lots of options for that, and I'll leave that to the listener. So I'm going to hit enter there, and then I'm ready to run my LinchPin command. So we're finally to the point where we can run a LinchPin up. So as you see here, I'm going to time it so you can kind of see how long it takes. I'm going to pass in the creds path. Now I mentioned earlier that I'm using this one here as an example. This is the real one, and it'll actually look for the clouds.yaml in my topology, as I mentioned, and it will find it, and then it will pass that in automatically. And it will use this target right here, OS single test, which is the target I've listed here. If you don't list a target, it'll do all the targets. And I'm going to do a LinchPin up command with this. So let's go ahead and hit enter and see what happens. This takes about 30 to 45 seconds, and then it will return and it will run that hook also. So there goes the hook. And now it's running, and it's getting ready to ping it, and it pinged it, and it's successful. It took 51 seconds. Not too bad at all. So thank you very much. I hope you enjoyed the tutorial. If you have any questions, please let me know. You can join us on #LinchPin on Freenode, which is our IRC chat, or you can email us at linchpin@redhat.com, or we're on GitHub under the CentOS PazSig, or just search LinchPin on GitHub and you'll find us. Thanks very much. Appreciate it. Bye-bye.